So when two identical atoms are bound, it's purely covalent in this case. So this would be a pure covalent where the two atoms are identical. So that means that this blue sphere here is representing the electron cloud, and the two dots are representing the nuclei. And what they're showing here is that the electrons are shared equally between these two atoms, okay, purely covalent. When two different atoms are bound, one may have a greater attraction for the electrons, okay, and in that case, that one that has the greater attraction, that atom that has a greater attraction, might carry a partial negative charge. Okay, in this case, this is a covalent bond between two atoms where the electrons are not equally shared, and the way we model that is with this electron cloud, showing that the electron cloud is bigger around the atom that has the greater attraction for the electrons. And we actually use this symbol, it's a little delta with a negative, so that this actually has what we would consider a partial negative charge, and the delta positive is a partial positive charge. So the electrons are not evenly distributed in this case. In this case, when the electrons are not equally distributed within the bond, it's called a polar covalent bond, okay? And you can measure, there's different degrees of polar covalent bonds, and you measure it using a dipole moment, okay? And that's just putting the molecule in an electric field and measuring its dipole moment within the electric field. So there are different degrees of polarity. And when one atom has a much stronger attraction to the electrons than the other, then the electron may be donated, yielding an ionic bond. So this is the case of the ionic. This is the pure covalent, and this is the case that's in between, and this is called the polar covalent bond. Okay, so polar, the word polar means has two poles, a negative pole and a positive pole, because the electrons are not equally distributed. So a polar covalent bond would fall in between the extreme of purely covalent and purely ionic. All right, so there's something, so the bonds then may have an unequal distribution of electrons.